All right, so today we're looking at, we're starting with 2.3, linear functions and slope, wherein our slope is represented by m, and we can calculate it by using the formula of y2 minus y1 over x2 minus x1, or we actually can do y1 minus y2 over x1 minus x2, as long as we stay consistent in our substitution. In other words, if we substitute y2 first in our equation, then substitute x2 first on the bottom. And then if we decide to do y1 first in the numerator, then use x1 first in the denominator. If we stay consistent with that thought process, we'll get the same value regardless. And the other side of it is that, or the other piece of this relationship is rise over run. And that's normally used when graphing. So the 2 points, x1, y1, and x2, y2 are any points on the line that you're referring to. And so that's going to actually give us the ability to calculate or put a number on the slope, the steepness or the slant of a line, just like when you talk about slope of a mountain, slope of a roof, or a ramp. It's the same idea, but we put a numerical value to it. Of course, if I scroll up too quick, let me know. Okay, so the first one, find the slope of the line passing through the points -3, -1, and -2, 4. All right, so you label the points, whichever call whichever one 0.1 and the other one 0.2. So I call it -3, -1.1. That's why it's x1, y1. And -2, 4.2. That's why that one is called x2, y2. Then we're going to substitute it into the slope formula accordingly. Here, I'm going to use the first one as y2 minus y1 over x2 minus x1. I'm going to do the other way as well, just to show you that either way you'll come up with the same value. Just remember, when you're doing it on your own, you only have to do it one way. All right. So over here, we have y2 minus y1 over x2 minus x1. So y2 is 4, y1 is -1. So be careful here. Try to emphasize the fact that you're substituting a negative. Try not to lose a negative when you're substituting into the formula. So the middle, you have a minus sign in there, and you're substituting in -1. A lot of people make a mistake and lose a negative. Make sure you don't. Then plug in for x2, -2, and then -3 for x1. Negative to a negative turns positive, so that's 4 plus 1, -2 plus 3. Add them together, that's 5 over 1, which is just 5. Now, if your slope ends up being a fraction, that's fine. You don't convert them to a decimal or anything like that. You leave it in fractional form. Here, 5 over 1, the simplest way of expressing that is 5. So that's why we did that. Now over here, we're going to substitute in y1 first on top, then x1 first on bottom. So y1 is -1, y2 is 4, x1 is -3, and x2 is -2. So when you go ahead and simplify that, that'll be -5 over -1, which is +5. So either way you see that, you'll get +5. You just have to be consistent in the way you substitute in your values. All right. Let's do that one more time. We have -3, 4, and 2, -2. So x1, y1 is -3, 4. 2, -2 will be x2, y2. So y2 minus y1. I need this over here. So y2 minus y1 over x2 minus x1, that'll be -2 minus 4 over 2 minus -3. So when you simplify that, that'll be -6 over 5. And that will be your slope. problems. All right, here we have basic behaviors of slopes. So if you follow your graph going from left to right, your slope is positive. If it goes up, I should say. Then if you follow your graph as it going from left to right, if it goes down, your line goes down, your slope is negative. So once again, if you follow your graph, your line, and it goes from left to right, and it goes up, your slope is positive. If it goes down, your slope is negative. Horizontal line, your slope is 0. Vertical line, the slope is undefined. All right. All right. So let's look at graphing using the slopes. Slope, the relationship of the part of the relationship from the slope that we will use to graph is rise over run, wherein your rise will represent the information that will tell us to go up or down, and the run on the denominator will tell us to go right or left. Now, what dictate whether we go right or left, up or down, is the fact that we have positive moves and negative moves. So our positive moves will be up and right, negative moves will be down and left. All right. So examples of that, if we have m equal to 2 over 3, that's a positive 2 over a positive 3. So that means up 2 and right 3. So those are both positive moves that we will make. We will go up 2 and right 3. Now, if we had a negative 10 over a positive 7, or let's say we had negative 10 sevenths, so we want to make sure we recognize that as not being negative over negative, because negative over negative is positive. So that negative sign has to go to either the top or the bottom, not both. So I always say just assign it to the top, and you always be safe with that. So we're talking about negative 10 over a positive 7. So that means I would go down 10 and then right 7, negative 10 over a positive 7. Now, if I decided to give the negative sign to the bottom number, that means I would have a positive 10 over a negative 7. So that means I will go up 10, left 7. So either way, I will still be on the same line. So we talk about right here. See, yeah, I erased it now. So if I have this point and I go down 10 and right 7, it'll put me here. But then if I go up 10, left 7, it'll put me up here, which is still the same line. So I just have to make sure I do things correctly. I will still get the same line. Yeah, and that'll be all right. All right. Questions? All right. Slope-intercept form. Here, y equal to mx plus b. If our linear equation is solved for y and simplified as much as possible, what's sitting in front of x will be our slope. The other number will be our y-intercept. So when I look at y equal to 2/3 x minus 1, what's sitting in front of x is our slope. So be careful with that. Sometimes people make the mistake of writing 2/3 x and they include x as a part of the slope, when x is not a part of the slope. 2/3 is the slope. So please don't make that mistake. Don't include x as a part of your answer, as if they were to ask you what is the slope. It's just the 2/3. It's just whatever's sitting in front of x. Then the other number is your y-intercept. Same thing here. If I have y equal to negative 4x plus 3, The slope is -4, and the y-intercept is 3. All right, so using this information to graph, if I have that equation of y equal to 2/3 x minus 1, we already mentioned what's sitting in front of x is our slope, so that's 2/3, +2 over +3. So that means up 2, right 3. Then also we have the y-intercept back here, which is -1. Now, -1 as a coordinate will be 0, -1. In other words, if it's a y-intercept, remember we talked about intercepts before, for y-intercepts, x is always 0. So as a coordinate, that's going to be 0, -1. So that's the information that you'll always be able to pull out of the equation, your slope, which is directions, to go up and right, down, left, whichever way they tell you, and they give you the y-intercept. And as a coordinate, that's 0 and that number. So in the green, we have the instructions on how we will use this information to graph. The first thing you would do is graph the y-intercept. So that's what we did right here in the blue dot. We graph the y-intercept right here. Then from that y-intercept, notice we said from the y-intercept, use the slope to generate another point from the y-intercept. We're not going to go to the origin. You only go to the origin to graph a point if you have a point. But we have a y-intercept. So what we're going to do is go to the y-intercept and go up to right 3. And that will be our line. Once again, you don't go to the origin with the slope. You go to the y-intercept with that slope. And then go up 2 and right 3. And that will give you another point that's on the line. All right. Questions. If you're still copying, let me know. Good. Okay, good. So the next one is y equal to -5x plus 4. Once again, extract the information from the equation. We have our slope is -5. And since that's just a number -5, that would be -5 over 1. And it's -5 over +1, so it means I go down 5, right 1. 4 is my y-intercept, so that means that point would be 0, 4. There's always 0 in that number. All right. So first thing we do is graph 0, 4. That's what we have right here. Blue dot is 0, 4. Now from 0, 4, I go down 4. So 1, 2, 3, 4, 5. I said down 4. I meant down 5. Sorry about that. Go down 5 and then to the right 1, which is right here. And then from there, oh, that's my point. Let's see if I can get it this time. Yep. So from there, that'll be our line. All right. Questions before we look at the point slope formula? All right. We have our point slope formula. y minus y1 equal to m times x minus x1, where m is our slope and x1, y1 is just any point on the line. All right, so write an equation of the line that passes through negative 1, 3 with a slope of 4. So here's the given information that we took from the problem. We have a slope of 4 and the line passes through negative 1, 3. So we want to plug into our equation the values for m, x1, and y1. Don't forget a regular equation has x and y in it. So we look at y equal to 2x plus 1. So it has x and y in it. So we're not trying to get rid of or substitute in for x and y. We're talking about x1, m, and y1. And so that's why I have these red arrows right here, just signifying those are the values that we're going to plug in for. So 3 goes in for y1, 4 goes in for m, and then negative 1 goes in for x1. Once again, don't lose a negative in your substitution. That'll leave us with y minus 3 equal to 4x plus 4. And then from there, we want to add 3 to both sides so that we can simplify our equation as much as possible to the equation, to the expression of y equal to 4x plus 7. All right, any questions? All right, so let's do that one more time. Here we have write the equation of the line that passes through 8, 5 with the slope of negative 1/4. So once again, here's the information that we can extract from the problem. Our slope is negative 1/4. Then our point x1, y1, which is going to be 8, 5 for us. So we want to substitute into the equation accordingly. We want to use our point slope formula because we have a point and a slope. So m is our slope. That's negative 1/4. And plug in 5 for y1 and then 8 for x1. We're going to distribute negative 1/4 to each term, and then here is the breakdown of that multiplication of the fraction. Why does it keep erasing that? There we go. So negative 1/4 times that negative 8, that ends up to being 8 over 4, which is just 2. So, yeah. And then we will add 5 to both sides. And that will give us the equation of y equal to negative 1/4 x plus 7. All right, questions. look at the next section. More on slopes. So we're looking at parallel lines. Parallel lines are lines that do not cross or touch. And that means that the slopes will be the same. That's going to be key for us in dealing with parallel lines, that we recognize that the slopes are the same. All right. Perpendicular lines, lines that intersect at a 90-degree angle, and their slopes are negative reciprocals of each other. And don't forget, you can never assume that you have 90-degree angles. You can never assume that you have perpendicular lines. So something has to let you know that you're dealing with 90-degree angles. So, either you need to see that square that's in there that it's pointing to, or it needs to be saying the directions or the wording that you have perpendicular lines or there's a 90-degree there, because you never can assume that you have 90 degrees. Just throwing that out there. All right, so just make sure we're okay with what negative reciprocals are. A regular reciprocal, just general reciprocals, is just flipping the fraction. So it has nothing to do with your signs, flipping the fraction. So 3/4, the reciprocal of 3/4 is 4/3. The reciprocal of negative 10 over 7 is negative 7 over 10. The reciprocal of 5 is 1/5. But what we need for perpendicular lines is the negative reciprocal. So negative mathematically means opposite. So if we have 3/4, the negative reciprocal of 3/4 would be negative 4/3. If we have negative 10 over 7, the negative reciprocal of negative 10 over 7 is 7 over 10. So notice what we're doing is that we're flipping the fraction and changing the sign. So that's what it means to be a negative reciprocal. You're going to flip the fraction and change the sign. And then 5, the negative reciprocal of 5 is negative 1 over 5. All right, here's just a mini chart just to emphasize the relationship between the slope and a line that's parallel to it versus being perpendicular. So if we have a line and the original line has a slope of 8/3, if I want a line that's parallel to it, that slope would be the same, which is 8/3. Now, if I want a line that's perpendicular to it, that slope would be negative 3 over 8. All right. In the second column, if my slope, the slope of the line that I have is negative 9 over 11, and I want a line that's parallel to it, it would still be negative 9 over 11. Remember, parallel lines have to have the same slope. Then if I want a line that's perpendicular to it, then I will have a slope of 11 over 9. Any questions? All right. So here we want to write the equation of the line passing through negative 3, 1, and parallel to the line y equal to 2x plus 1. So the equation that we have is y equal to 2x plus 1. which I wrote right here. And because that equation is solved for y, we already know what the slope is. We can pull the slope from that equation, and that's going to be 2. You know what? Once your equation is solved for y, whatever's sitting in front of x is your slope. So the slope of the line that we have is 2. We want a line that's parallel to that. So that means that slope would also be 2. All right. All right. So the given information that we have now is the fact that our slope is going to be 2, and the line that passes through that, and there's going to be a line that passes through the point, -3, 1. And we got that, of course, from the equation, from the problem as well. Then we plug it into the point slope formula. 1 for y1, 2 for m, and then -3 for x1. Distribute that 2. So that'll be y minus 1 equal to 2x plus 6. Then we will add 1 to both sides. Y is equal to 2x plus 1. All right, any questions? Any questions? All right, let's do another one. Write the equation of the line passing through 3, -5, and perpendicular to x plus 4y minus 8 equal to 0, and then express in general form. So we'll talk about what that means when we get down to it. But the first thing we recognize that we have this equation x plus 4y minus 8 equal to 0, and we need to solve it for y first so we can pick out what the slope is. So I subtract the x and add 8 to both sides of the equation so that they will cancel out on the left. So that'll be 4y equal to -x plus 8. Then divide by 4. That would be y equal to -x over 4 plus 8 over 4. And that means I have my equation as y equal to -1 over 4x plus 2. All right, so -1 over 4 is our original slope. Now a line or slope, the slope of the line is perpendicular to that line that we have, means that we need to flip the fraction and use the opposite sign. So that'll be a +4, +4 over 1. All right. So now that you have your slope and the point, you plug it into the point slope formula. Y minus y1 equal to m times x minus x1. Plug it in -5 for y1, 4 for m, and then 3 for x1. All right, so distribute the 4. That'll be 4x minus 12 on the right. On the left, we will have y plus 5. So in order to finish solving, we'll subtract 5 from both sides. Fives cancel, leaving us with y equal to 4x minus 17. All right, so now we need to put our answer in general form. General form is ax plus by plus c equal to 0. We look at what we had originally. That's what they did here. Basically, they just set one side equal to 0, put all of your terms on one side of the equation. So what I did here was I subtracted y from both sides. 4x minus y minus 17 is equal to 0. All right, any questions? All right. 2.5 transformations of functions. So I don't, yeah. So I don't do a lot of lecture out of 2.5 because it's graphs, and just reemphasizing the graphing process. And you're gonna have some basic parent functions. And in my math lab, they don't even, get you to graph. Basically, they put graphs up and you have to choose which is the right one. So you should have some type of graphing tool that will enable you to be able to graph the functions that are placed in front of you. So we have 6 basic or parent functions. We have y equal to x, which is your linear equation. Then we have our quadratic equation, which will give us a parabola. So that's y equal to x squared. Cubic equation, y equal to x cubed. And these are our general shapes of these functions and these graphs. Square root of x, the cube root of x, and then the absolute value of x. All right. And so what happens in this section is they talk about transformations, how adding one or subtracting one inside of the parentheses bit. Let me erase this so we can see it. So adding one inside of your square versus adding one on the outside of your square, what that means versus subtracting one on the inside of your square, subtracting one on the outside of your square. Matter of fact, that is on, they have the summary of those transformations on page. Give me a second. I thought I had it written up there already. Summary is on page 291. So, when you get into the graphs, dealing with the graphs, if you have questions with them, always feel free to ask. But like I said, I don't spend much lecture time on graphing because we've been graphing up to this point. And really, you can throw them in a graphing tool and it will show you the shifts, the difference between x squared plus 1 and x plus 1 squared, shifting up or down, left or right. So check those out and see if you have any questions. Let's see, how long is 2.6? Okay, that's not bad. Okay. Yep. So we'll do 2 point. All right, so let's look at 2.6, and then we'll be done for today. So the combinations of functions and composite functions. So find the domain. So we're looking for all the values that can be used for x. Or in other words, all values that can be plugged into the equation for x. So to find the values that can be used, you want to look for the values that cannot be used. It'll be easier to look for the values that cannot be used. All right. So they want us to find the domain of each. So you want to ask yourself, when you're looking at domain, is there a value that can be plugged in for x that will make the equation undefined? All right. So when you look at x squared minus 7x, the answer is no. There's nothing you can plug in to this function that will make it undefined. So there has to be some type of pre-existing condition for your function that you know that when I do certain things, it will be undefined in this scenario. So there's nothing I can plug in to x squared minus 7x to make it undefined. So you'll see what I mean in a second when I talk about a pre-existing condition that you know that when I do this, it will make the function undefined. But in this case, your domain would be negative infinity to infinity. All values can be plugged in without any problems. All right. The next one, we're looking at a rational expression, or in other words, a fraction. So, hold on 1 second. Sorry about that. So we have g of x is equal to 2 over x minus 5. Can I make this fraction undefined? Yes. Fractions are undefined when the denominator is 0. So that's what we're talking about, a pre-existing condition for this equation. We know that whenever my denominator is 0, I have undefined in my fraction. Okay? So we want to know, when is our denominator equal to 0? So if you want to know that, you set the denominator equal to 0 and then solve. If I scroll up too far, let me know. So x minus 5 equal to 0. When you solve, you add 5 to both sides. X is equal to 5. And this is the value that cannot be used in the equation. If I were to plug 5 into that equation, I would get 0 in the denominator, because x minus 5 is in that denominator. 5 minus 5 is 0. So that means that's the only value that I cannot use. So my domain will be everything else. So notice I use parentheses on my 5. In my domain, it says negative infinity to 5, and then 5 to positive infinity. That means I can get as close to 5 on the left side of it, as close to 5 as I want to on the right side of it. I just cannot use the 5. All right. Similar scenario here. We have h of x is equal to 3x plus 2 over x squared minus 2x minus 3. Set the denominator equal to 0 and solve. Once again, we want to know, when is our denominator equal to 0? So we're solving the quadratic equation at the bottom, of the quadratic expression down bottom, by setting it equal to 0 and making it an equation. X squared minus 2x minus 3 equal to 0. Factor it. We have x minus 3 times x plus 1. Set each part equal to 0. X minus 3 equal to 0 will yield 3 as a solution. X plus 1 equal to 0 will yield negative 1. All right. So these are the values that cannot be used. Those cannot use these two values. Before it was just 1, this time it's 2. So here, just want to make sure we emphasize the intervals. So we cannot use negative 1 or 3, but we can use everything else. So that means we would go from negative infinity to negative 1, negative 1 to 3, and then 3 to positive infinity. All right. Questions? Any questions? All right. Any questions? All right. So the next one, I believe that's the last one like this. We have the square root of 3x plus 12. And it says, can I make this expression undefined? In other words, when is a radical undefined? So you cannot take the square root of a negative number. And so here I was just emphasizing that that's called the radicand. What's under the radical? It's called the radicand. You know, this is the radical, and then what's under it is radicand. So we cannot take the square root of a negative number. So we want to know, and well, before I say that, we want to know, when is the radicand greater than or equal to 0? Because we can take the square root of 0, because 0 times 0 is 0. So we want to know, when is it greater than or equal to 0? Because remember, greater than 0 are all of our positive values, and those are the values that we can use. So we set 3x plus 12, which was under the radical, greater than or equal to 0. Solve for x, and we have x is greater than or equal to negative 4. Once again, let me know if I'm scrolling up too fast. All right. So that means our domain would be bracket this time because we're okay with using -4. We just cannot use anything less than -4. So there's bracket over the -4 to positive infinity, parentheses over the positive infinity. All right. Questions? Any questions? All right, here we have the algebra functions. F plus g of x is just f of x plus g of x, then f minus g of x, f of x minus g of x, and f times g of x, just multiplying the functions together, and then the quotient, it's just dividing them. So it's just a shorthand way of writing those information, or writing those instructions as to how you will handle those equations. All right, so the next one, f of x is equal to 2x minus 1, and g of x is equal to x squared plus x minus 2. And we want to find each. So the first one, f plus g of x, all that is adding our two functions together. So we have 2x minus 1 plus x squared plus x minus 2. So basically all we would do is combine our like terms. So that'll be x squared as our first term because nothing can add to that. Then 2x plus x, which is 3x. Then -1 plus -2, that'll be -3. All right. Next one, f of x minus g of x. Subtracting those functions. Don't forget to distribute the negative to the one that follows the parentheses. No, distribute the negative to the parentheses that follows it. Yeah. So that'll be 2x minus 1 minus x squared minus x minus 2. So negative x squared plus x plus 1 after you combine your like terms. All right. Questions? Any questions? Next one, multiplying them together. F times g of x. So that's going to be 2x minus 1 times x squared plus x minus 2. So you would distribute each term from the first parentheses into each term of the second parentheses. All right, so 2x times x squared, 2x cubed, then that's plus 2x squared, and that's minus 4x. Then -1, that'll be negative x squared minus x plus 2. All right, combine your like terms. 2x cubed couldn't combine with anything, but we had 2x squared minus x squared, which is 1x squared. Then we had negative 4x and a negative 1x, which would be negative 5x, and have a 2 in the back. All right. And last one like this, f over g of x. So you just take the functions, take f of x and place it over g of x. And if they could simplify, then you would, but there's nothing that can be done in this case. So it'll just be 2x minus 1 over x squared plus x minus 2. Any questions? All right, so this next one here, someone must have asked a question. So if there was a number in there instead of the x, but an actual number here. And so all I was saying is that one way of handling it is just by plugging in a 2 wherever you see x after you created that equation. So, or after you created that function, you plug in 2 where you see x. So it'd be 2 times 2 minus 1 over 2 squared plus 2 minus 2. And that'll be 4 minus 1 over 4 plus 2 minus 2. So that will simplify to 3/4. All right, any questions? Let's see, I think we have just this, and yep, that'll be it. All right, so last thing of the day, the composition of functions. So we have fog of x, and we have this little symbol right here that looks like a little circle. When you see it in the math symbolism, when you see it, it's just a circle. But it's a little different than any other circle that you'll see. So that's the composition of your function. That's fog of x. That means you take the function g, plug it into f. And then golf of x, you take the function f and plug it into g. All right. So given these functions right here, they give us f of x is equal to 3x minus 4. G of x is equal to x squared minus 2x plus 6. They want us to find fog of x. So it means we're going to take this function, this whole function of g, and plug it in where we see x into f. So that's 3 times x squared plus 2x minus 6, and then that's minus 4. I said minus 6. 3x squared, 3 times x squared minus 2x plus 6 minus 4. Then you'll distribute. So that would be 3x squared minus 6x plus 18. That minus 4 is still back there. And 18 minus 4 is positive 14. So 3x squared minus 6x plus 14. All right. So now golf of x is actually taking the f function. If you look at what we have here, taking f function and plugging it in to g. So we're going to take this 3x minus 4, and plug it in where we see x into that g function. So that's what we have here. 3x squared, 3x minus 4 squared minus 2 times 3x minus 4 plus 6. So that 3x minus 4 squared is over here in this purple. You have to expand that out. 3x minus 4 times 3x minus 4. And then distribute that negative 2 into the parentheses. That'll be negative 6x plus 8. So that full expansion is 9x squared minus 24x plus 16 minus 6x plus 8 plus 6. Combine your like terms. So we have that negative 24x and a negative 6x will give us negative 30x, 16, 8, and 6 will give us 30. So they give us the expression of 9x squared minus 30x plus 30. So before we look at C, questions, any questions? All right, so here we have golf of 1. So before we just found golf of x, now they're saying put a 1 in there for x, then calculate it. So we can do that one of two ways. So we're just talking about from scratch. This is how we will look at it. That's f of 1 that we're going to plug into G. Because you remember before we had f of x that we would plug into G, but now we have a 1 in there for x. So we can find f of 1. So plug 1 into f. 3 times 1 minus 4, that's 3 minus 4, which is negative 1. So f of 1 is equal to negative 1. So now we plug that in right here into G. And negative 1 squared minus 2 times negative 1 plus 6 is what we have after our substitution. When you simplify that, you'll get 9 for your answer. Now, the other way of doing it, since we have done this already, we can just plug 1 in to that expression. And that'll be 9 times 1 squared minus 30 times 1 plus 30. So the 30 times 1 and the 9 times 1 is just 9 minus 30 plus 30. Those 30s cancel, leaving us with just 9. So notice we still get the same answer. All right. Questions? Any questions? Any questions? All right. So try the stuff out. See if you get stuck on anything. Next class, we'll look at 2.7 and 2.8. And then we'll go from there. All right. Any questions or concerns before we close out? All right. If not, have a good one. Be safe, and I will see you on next class.